Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial demo um, entitled Palindrome Tester. We're in the Java course, and we're working on Chapter 5 of the Reggies and Step book. And we're trying to get a hold of some programming techniques, and we have a number of tools and techniques. And one of the things that we've learned recently is how to start taking control of and exploiting the Boolean type. Okay, so we're going to do that by testing character strings for palindromes. So let's begin by going over and taking a look at Wikipedia and finding out what a palindrome is according to them. Okay, so here we are. Here's the palindrome entry at Wikipedia. A palindrome is a word, phrase, number, or other sequence of characters which reads the same backward or forward. Allowances may be made for adjustments to capital letters, punctuation, and word dividers. So examples in English: a man, a plan, a canal, Panama. Okay. Now, a man, a plan, a canal, Panama is only a palindrome if you ignore both the capitalization and the punctuation. The classic example of a palindrome are the classic examples are words. Okay, and some of the words that you might see used a lot. Radar. Okay, it's the same backwards and forward. Kayak. Okay, rotor. All right. So here's what I'm going to do. I'm going to build code that tests a character string for being a palindrome. And of course, I'm going to write a method called isPalindrome. Okay, and it's going to take as input, it's going to accept a string parameter, and it's going to return a Boolean. And it's going to return true if the string that we got is a palindrome, and it's going to return false if not. Now, I don't even want to make mine so sophisticated, right? So I've decided that I want to detect single words, okay? So, and I want to detect phrases that are palindromes. I'm not going to worry about capitalization, but I am going to worry about spaces and commas. Okay, so for instance, in my test, rotor will pass. All these words will pass. Okay. Sentences and phrases, some will and some won't. Okay. Now there's a classic one here that I'm trying to find. Now I can't find it. But if we're going to do a sentence, I just want to say that it's got to be the same backwards and forward. Every place there's a space, there needs to be a space, and every place that there's a comma, there needs to be a comma. Okay, so some of these do not conform to that rule. Okay, so there we go. All right, so that's what we're trying to do. Those are the requirements as they sit right now. All righty. Having a hard time finding what I want here. Oh, all right. Now I have what I want. Okay. So we're in the Chapter 5 demo project. in the default package, I want to create a new class, and I'm going to call it PalindromeTester. PalindromeTester. And it's going to have a main because this is a conventionally tested program. So it's going to include sort of a testing harness as well as the working code. Okay, so let's look at this. Let's get started. All right, so what do I want to do? Well, first, I'd like to define a variable that's going to hold the candidate character string, so I can see if it is in fact a palindrome. Okay. All right. So let's declare string. That's it's a class-based type, and I'm gonna call it candidate. Okay. And I'm going to say that it is equal to, and I'm going to pick one of the easy words like kayak. Okay, so I'm expecting that to pass. All right, I'll test for failure at the appropriate time later. And now I don't have a method that called isPalindrome yet. But I'm going to code as though I do, and then I'm going to use one of the Eclipse features to have it create the shell for the method, which I think is a good practice. So I'm going to say if, then my test is going to be isPalindrome, because that's going to be the name of my method, and I'm going to pass a candidate in. So if candidate is a palindrome, then let's say let's just do an easy version. So let's say sysout. Oh, sorry, I didn't properly spell that. Sysout. Let's print yes. Okay. Else, let's print no. Okay. Now, eventually, I'd like to have a more sophisticated printing that is going to say, it's going to repeat whatever we gave it, like kayak is a palindrome or kayak is not a palindrome. But that's fancy. Let's get it to work before we make it fancy. All right, this is good, except for the fact that we haven't done any of the hard work. And that's because we've taken all the hard work and we've confined it to the method isPalindrome. And let's, if we hover over the error that we don't have it, sorry, come down here and I'll come up and hover, it offers a quick fix to create the method. Let's go ahead and create it. Well, let's see. It's static. That's good. It made it private. Now, we haven't really learned about private and public, but private, for now, that's good. Okay. It returns a Boolean. It's called isPalindrome. And it takes as a parameter a string, which it's going to call candidate. It's going to call the same thing. Now, in order to remind me, and especially you, that parameters are not the same as the data that are in the calling code, I'm going to use another name for it. Okay, and I'm just going to call it, this is a classic thing to do, I call it the candidate, just to distinguish between the two. Okay, all right, so let's create some code. Let's have some room here. Now we need to return some kind of value. Right now we're just returning false. False is good. Typically in this kind of a method, you're either going to assume that it's true and then look for cases where it's false, okay? Or you're going to assume that it's false and look for cases where it's true. And you'll see because there are a couple things that can make it false, I'm gonna make the default be false, and then we're going to try to detect when it truly is a palindrome. Okay. So let's do this. Let's declare a Boolean answer equals false. Okay. And then we return answer. So right now we're going to have false negatives. If we call with kayak right now, we're going to get back the answer false, and we're going to print out no. Let's just see what that looks like. Okay. Run as Java application, no. Okay, well, that's the wrong answer. Okay, so I'm going to say the first thing I'm going to want to check for, and this is really the first time I've done it in this course, so I'm going to take a little bit of time to talk about it. I'm going to check for nulls. Okay, now what's a null? Well, a null is a potential value for any variable that has a type that is defined by the name of a class. So a string that's not really pointing at any particular string object, a string variable that's not pointing at any string object, the other value that it can say, I'm not pointing at anything right now, is null, N-U-L-L. Okay? Well, that can mean a lot of things. Okay? But it definitely means that you can't try to use that object, that string object, and start to call the methods on it. Okay? Now, we're going to try to compare this string to another string, and the other string is a copy of our string that's been reversed, right? Does that make sense? But what if our string isn't a proper string? What if somebody was a bad citizen and they sent us a null? Now, well, we have to decide what to do. Eventually, we're going to learn how to blow things up. So we're going to do this thing called throw an exception. So if somebody throws us a null when we're not expecting one, well, we'll just throw an exception. It'll stop the whole program. But when you really think of it, with regard to the question at hand, is it a palindrome? Well, if it's not a proper string, it's definitely not a palindrome. Okay? So we could simply pass back the answer false. Okay? So let's do this. Let's say if the candidate is not equal, bang, equal, null, then we're going to exaggerate and say that it's true. So it's answer equals true, which is not true. Okay? Okay, and I'm sorry, we're returning false. We should be returning answer. I bet you've been out there saying, Kevin, you're returning the wrong thing. You're returning the wrong thing. Okay, so now what we've got is we get past the proper string, we're going to exaggerate and say, yes, we know it's a palindrome. If we get past a null by a bad citizen, we're going to say, no, it's not. Okay, we're currently set up with kayak. So that should get back a yes. Let's save. We've already saved. Let's run a test. Yes. Okay. How about we just test it with a null? Okay, so instead of the string kayak, there's a literal value, null. It's not in quotes. You can see how it lights up in the editor like the other keywords. Okay, so let's see. If we send that, then it should be keeping its initial value of false and returning it. We should get back a false and we should print out no. So let's give it a test. No, we print out no. So what I like here is that we're doing what I call defensive programming. We are saying, okay, what's reasonable input for us to get? And then we're saying, well, what's even possible unreasonable input for us to get? And can we create our code to exhibit reasonable behavior even in the face of unreasonable input? And in this case, it's pretty easy because it's pretty easy to say that a null is definitely not a palindrome. Okay? So that kind of made it easy. Okay. Now, let's see what we're going to do. Okay. Let's, instead of just assuming that it's equal, let's do the following thing. In order to know if the candidate is a palindrome, we need to have another string that's the reverse of that. And if the candidate is equal to the reverse of the candidate, then we got a palindrome on our hands. Okay? We've already assumed that we don't. Okay? But if we do, we're going to have to turn the answer to true. Okay? So let's declare another string variable, not a strong variable, string variable. And let's call it reverse candidate. And you can kind of get the meaning from that. Equals, and we're going to need another method that reverses the string. Now, unfortunately, the string class doesn't come with a reverse method. There is another class that has one that we could use, but then we'd have to learn about that class, and then we wouldn't have the benefit of being able to write a cute little method that reverses the contents of a character string. Okay, so let's imagine we have a method called reverse, and we're going to pass it the candidate. Okay. Well, that's great, except that we haven't written that yet. We're going to have to do it. Okay, that's fine. So now, provided that we had gotten the reverse back, we can say if the candidate. Now, can we do an equal test? Well, we could, but we won't get a proper answer. Okay, so remember we've got a string, which is an object, and all these object-oriented things that we want to compare, they need to implement their own method called equals. Luckily, the people who built the string class created one for us, so we're going to say dot equals. It's going to return a Boolean. And what do we want to compare it to? Well, we want to compare it to reverse candidate. So if they're equal, well, gosh, we have a real palindrome. Answer equal true. Okay, well, what if they're not equal? Well, we don't have to do anything because we assumed false to begin with. So it's already false. Okay, if we hadn't assumed false, then we'd have to say else, answer equals false, and all that. But the trick of assuming false to begin with makes the code a little simpler here. Okay, all right, so that looks good. All right, so this is going to work great, except that we don't have a method that reverses a character string. Well, that shouldn't be too hard. Now, if you are new to programming, and you might say, I bet I can Google up a method to reverse a character string. And in fact, there are several examples on the net of code to do what we're going to do here. Being as long of tooth as I am, well, I can conjure up one myself. So again, I'm going to hover over the error. I'm going to take the quick fix and have it create the method for me. Okay, so again, private static, it returns a string. It's called reverse. It takes a string called the candidate. Oh, maybe I don't want it called the candidate. Again, I want to accentuate the fact that this is that we're dealing with the parameter here instead of somehow we're magically able to see the parameter from the previous method. So I like calling this forward string. I'm going to call this forward string. Okay. And again, I'm going to take a deliberate approach. Okay, so we have to return a string. So I'm going to declare a string called answer. And I'm going to say that it's equal to the empty string. Okay, because I'm going to create a loop that is going to add on, okay, all of the characters one at a time from the back to the front. Okay, so we're going to start with an empty string, and then we're going to concatenate on the last character, then the next to the last, then the next to the last. What if we have no characters at all? What if somebody passed us a zero-length string? Well, that would be nasty. Well, people do that. Okay. Well, this would be fine, because if somebody passes a zero-length string, then I would like to code my loop, which is going to come immediately after this, such that it doesn't do anything. And so my default answer is the empty string. So if I get an empty string in, I'm sending an empty string back. Okay, I have to remember to return answer. Okay, that looks good. Now, what if somebody passed us a null? Oh, that would be a mean thing to do, wouldn't it? Well, they could. Okay, let's be defensive. Let's check and make sure that if somebody is nasty enough to pass us a null, that we do the reasonable thing. Typically, in this kind of situation, if somebody sends you a null, you're entitled to send them back a null. So what's the reverse of a null? Well, is a null the reverse of a null? No, but it's good enough, right? So a lot of people say garbage in, garbage out. Now, we eventually are going to learn enough sophistication that we would be able to detect the null, and we could throw an exception which would stop the action. But there's a programming style which I've adopted that says if somebody sends you a null and you send a null back, that's kind of okay. So that's what we're going to do. So we're going to say if forward string, and we can do an equal test for null. Equal for null is going to work because we're not comparing, there is no null object, okay? Null says, is that variable not pointing to anything? Okay, so it's a special value. Okay, so you can do an equal test. So if it's equal to null, well then let's just send the answer null back. So let's say answer equals null. Okay? All right, so we've taken care of the tricksters. Now we're going to have a loop. So let's say else, let's do the work to convert the loop. Okay? Well, we're going to need a for loop. Okay? Now, we're going to need a for loop that goes backwards. Okay? Because we're going to need to build the string first character first, and then we want to, because we want to do a plus equals. Okay, so we want to keep concatenating on one character at a time. So we want to start with the first one that we want, and of course that's the last one in forward string. Okay, so let's have a for loop, and we can use I again. So oh, we haven't even used I. So for int I equals, oh, now where do we begin? Well, we begin approximately at the length of forward string. Okay, but it's not exactly there. It's that -1. Why is that? Well, if forward string is too long, then the indexes are 0 and 1. Okay, so we want to start to point 1 lower than the length. So we're going to say for int I equals forward string dot length -1. Okay. Now we probably can get away with no parentheses around this, but I like parentheses around this. So we're just gonna put parentheses around that because I'm a parenthetical guy. Somehow I missed the extra paren, so we've got parentheses there. So that's where we start. Okay, now we want to do it as long as we're pointing at one of the characters. Now they're numbered from 0 to length -1, so we want to keep doing it until we get down to 0, but not less than 0. Okay, so I'm going to say as long as I is greater than or equal to 0, I'm going to want to move it. Okay, and now of course since we're going backwards, we want to do I -. Okay, that looks good. So now we just want to take a forward string char at I and append it to the end of answer. So we can say answer plus equals forward string dot char at I, semicolon. So now, provided that we have a real string, it's going to work. And I just want to point out that this code also works if somebody sent us a string of length 0. Why does it? Well, because we come in here and we calculate forward string length -1. So we have 0 -1 is a -1. It'll do the test is I greater than or equal to 0? No, it's not. So it will never do the work inside the loop. So we've taken care of a possibility that somebody sent us a null. We've also taken care of the possibility of somebody sent us a 0 length string. Pretty nice. Okay. That sounds good. So this should work. So let's do a little testing. Okay. So right now we've got null. Okay, we'll do a test with a null. Well, it should just give us back a false. Does it give us back a false? Yeah, gives us back a no. Okay, that's good. Let's put in something that's not a proper palindrome. Okay, so candidate equals, I'm just going to put my name, Kevin. Okay. Oh, I've got something that I did wrong. Okay. Kevin, let's test that. Well, that's no. And now let's look at radar. Is that going to test? Yes. It's going to text yes. Okay, that's good. Remember how I said that I wasn't going to allow you to have different spaces or punctuation, but I would allow you to have different capitalization. Well, this is not going to work the way I currently have it, because if I have a capital R on radar, it's gonna fail. No. How can I fix that? Well, let's go down to is palindrome and say, how could I not take into consideration differences in case? Well, it turns out that in addition to having the method equals, strings have the method equals ignore case. Okay, so let's save that and run that. Radar with a capital R passes. Okay, now we're pretty close. Okay. Let's do just a little more fancying up. Okay. So let's, in the case where this works, let's say, instead of yes, let's say candidate, let's print out that word, space, capital is, to emphasize is, a palindrome. Okay? And then let's, on the other one, we'll just say is not. Okay? So instead of no, let's say candidate, I'm going to say lowercase is, capital case not, is not a palindrome. Okay, so let's see that. So we've got radar, should say radar is a palindrome. Okay. And then we've got radars. Run that test. Radars is not a palindrome. And this could get more sophisticated. I have a version of this where in the printing, because I want to be able to put a phrase in, I put the candidate into quotation marks in the output. But right now I'm only doing words, so I'm okay. So this is the kind of thing where you could make something like this work, and then you could, over time, enhance it. You can enhance it such that it's not sensitive to the presence or absence of spaces. It's not sensitive to the presence or absence of punctuation, right? All we've done so far is to make it insensitive to differences in case. All right, but that's enough of a palindrome tester for us. So what have we learned? Well, the testing part of the code, this main, pretty basic stuff. We've been doing this for a long time. But the two methods are really good design, okay? Because the palindrome is not only, the method is palindrome is not only putting the code in a method, but we're passing back a Boolean such that it reads really well up in this code. The code that uses this is sometimes called the client code. So up in the client code in main, we say if is palindrome candidate. I think that, that reads like a children's book. That is really nice. And then again, we took all the complexity of reversing a character string, and we confined it to a method. Okay, so now we don't have an is palindrome that is bloated by having to do the reversing itself. It has relied upon a lower level method for reverse. And then the other thing that we've done is that in the case of is palindrome and reversed, we've done reasonable things if we get surprise input. In both cases, if somebody passes us a null, we're going to give back a reasonable answer. And if somebody passes us back a zero-length string, oh, we didn't test that yet. Let's do that. We're going to give back a reasonable answer. So let's take radars out of there, and let's see what happens. Now, I'm hoping it's going to say that it's not a palindrome. It says it is a palindrome. I'm not sure that's good behavior. I don't think an empty string should be a palindrome. Okay, so we got one more thing to fix. Okay. Well, I'm going to leave it for you to fix. Okay. That's what we're going to do. It's going to be extra credit. What I would do is inside of is a palindrome, after I check for null, then I would check and see if I had a zero-length string. And if I had said if I had a zero-length string, I don't have a palindrome by definition. Okay. I mean, it is the same backwards and forwards, but it's so trivial as is to not fit within the meaning of a palindrome. Okay, so we did something reasonable, but I think it's outside of the bounds of what we want. So I'm going to go back to radar and test it again. And I'm going to leave you with a version of Palindrome Tester that's imperfect and just at the point where you could perfect it yourself. And I'm going to say bye until next time. Bye-bye.